Find the derivative of the power series function f of z equals the summation k equals 0 to infinity of z to the k. So first of all, this is the function 1 over 1 minus z, because this is a geometric series with common ratio z. And the disk of convergence is centered at 0 and radius 1, because the coefficients are just 1, and the limit of the ratio, or the kth root of the coefficients, is 1. And the reciprocal of 1 is 1. So you could verify that the disk of convergence is this disk here. And we want the derivative. So we can write this out longhand. If k is 0, z to the 0 is 1, plus z squared, plus z cubed, etc. And so the derivative can be calculated term by term, and it will be 0 plus 1 plus 2z plus 3z squared plus 4z cubed, etc., which we can put back in the form summation k equals 0 to infinity of, it looks like we have, if we have z to the k for power 0, power 1, 2, 3, the coefficient is k plus 1 times z to the k. So there's a form of the derivative. Now, on the other hand, if we try to calculate the derivative by just putting the derivative operator inside of the summation, try to do it the short way, the shorthand way, instead of expanding out the summation, then we get summation k from 0 to infinity of k times z to the k minus 1. But actually k equals 0 is not quite correct here, because that would mean that our first term would be have this z to the power negative 1 in it. It would be 0 times z to the negative 1, but so we could start this because we're multiplying by 0, we could start it at 1. That would be another way to write it. And then we could do a change of index. We could let j equal k minus 1. And then this would be, if k is 1, j is 0. And when k goes to infinity, j is following right behind, also goes to infinity. K is j plus 1. And then z to the k minus 1 is j. And then we could get this form by just changing the j back to the letter k. So this is the preferred form here for f prime, with the same index of summation as the original problem, k. So we could either write it as k goes from 1 to infinity of kz to the k minus 1, which looks like the more normal bring down the exponent and subtract 1 from the exponent power rule. Or we can re-index so that our power of z is still k, and the coefficient is 1 more than the power of z, so k plus 1. But then we have to start at 0 instead of 1 in order to compensate, as shown here with the change of index. Okay, so there's the derivative of our power series function. So this is the summation k plus 1 times z to the k. And that would be the derivative of this function, which would be negative 1 over 1 minus z squared times minus 1. So that would be 1 over 1 minus z, quantity squared. So that's f prime of z. So we actually have a power series here for this function. Some side information.